Hey, welcome to the room. We have a really fun challenge in front of us in this video. It's actually going to end up being a multi-part video. I think it's just going to be too long. Also, it sort of breaks itself into fun sub-projects. Here's the problem we find ourselves in, the pickle, if you will. We have a mostly original 1962 Fender Stratocaster. The problem is the bridge pickup. In the bridge position, this is what we have left. Flatwork, pole pieces, all original, and a coil of wire that's been as closely matched to what we could grab relative to a vintage early 60s Strat. And so what we don't have is a pickup winder, because I'm honestly not going to sit there and wind 8,000 turns around this thing by hand, so we're going to design a little device to do that. But I want to take you through all the steps from designing something like this, through using some of the tools, the laser cutters and things you've seen in other videos that I've done at this point, and get ourselves a working pickup winder. And I think what we'll need to do here is be able to mount at least a single coil pickup. I'd like to be able to spin the pickup in both directions, possibly, just for future benefit, really, if we want to wind clockwise or counterclockwise. I think the most important thing is it's got to spin at a reasonable speed, and it also has to count, because again, we're not going to sit there and count, and at any reasonable speed you're not going to be able to. Okay, I was going to go in order and flash, like here's the design part, and then here's moving on to cutting. What I found was, though, I went through several iterations of parts, and, one second, I also went through some cardboard templates, see here? Just going through getting some things figured out. I also went through some failed parts. So learned along the way, and it was super fun, but ultimately we ended up building ourselves a really cool pickup winder. In fact, we call it the Sidewinder. Check this out. So here's our little, recently these videos I've had an infatuation with clear things, I guess. Anyway, this little device in front of us, Sidewinder, well, there's the Sidewinder part. Really, it's a motor in a shell. It's got a counter up here. It's got the ability to set our guides so that when we position a pickup on this flywheel and it spins, we have a way to direct the wire on here. This flywheel can spin in either direction under motor power. Spins at about 1,000 RPM, but it is controllable from 0 to 1,000 via this speed control. And then with this embedded counter, it does all of that nicely. You can power it up through the back here. So it's a really neat little device. Decided to call it the Sidewinder because it sounded cute, and obviously it winds on the side. So why not? Enjoy the design and build. All right, I hope this view is okay at the bench. We're gonna go through a lot of stuff. Like we were saying in the room, we're making a pickup winder. I mean, you need to spin a pickup. I mean, the key things you're looking for, or that you need to do, right? You need to spin a pickup. You need to be able to guide the wire onto the pickup. It has to spin at some sort of controlled speed. Can't be, too slow. It'll take you 8 years to wrap a pickup because it's thousands of turns. But too fast, and you could break the wire, or you could, not have a very controlled wind, even like scatterwound. I just mean the wire could go all over the place. But also, maybe even most importantly, you need to know how many winds are on the pickup as you wind it, because I'm shooting for a vintage Strat pickup, which is going to be in the 8,000-ish wind category. I'm not going to count them myself. That would be ridiculous. So in looking for parts that exist, and if you Google search or YouTube search DIY pickup winders, there are a lot of people who have found some parts that work. And I had debated programming like an Arduino counter or something, but for a couple dollars, they make some really interesting parts that'll do the job. And so now the design becomes getting all the parts, which we have in front of us, including some acrylic stock pieces that we'll make the box out of, the base out of, all that stuff. And then now it's like this iterative design process around fitting things in and measuring the parts that we bought so that we can mount them inside of our design that we're looking at. So let's take a look at the parts. We have a counter. This was like $7 or $8. I'll put the prices up. I'll put the total all-in price for the parts right now, and then also the prices per the part. This is a magnetic counter. There's a little magnet in the box too. So if you mount this guy, every time a magnet swings around something spinning, it will count. This was $7 or $8. So this addresses the knowing how many turns are on the pickup as long as we design the device correctly so that this little magnet will pass by the sensor every time. That's easy. That's also battery powered. Design improvement. Maybe we can make it wall plugged, but whatever. It's okay. That'll work for now. I'm sure it lasts forever. It's a little screen. We need to spin the pickup. So this was, I don't know, less than $20. It was like $10 or $15 or something. DC motor. It'll go 1,000 RPM, but we need a way to control it, which is this guy, little DC motor controller. This has both an on, if you could hear it, an on, and then also it's a pot, so it'll go from 0 to whatever the max speed is, in this case 1,000 RPM at the 12 volts. So, speaking of 12 volts, this will take 12 volts in and send it over to the motor at the right position of the potentiometer. Will tell the motor how fast to spin, how much power to send it, basically. So, 12 volt power supply, and then we have little fixins for mounting the power, getting the power into our designed box, and then all the components. We may power it up via switch. I debated. This is a little light up switch. We'll see if it works in a test. Really just so that we know that it's powered on, because this does turn off. I'm not worried about it being off. I'm just worried about knowing that the device is on or not. I mean, I guess technically it might just, if it was on and powered in, it might just start spinning. So, okay. Talk about these. These are drill guides, but I'm going to use them in conjunction with some stainless steel rods. And what we're going to do is design this device to, it'll spin a pickup in space here, and it'll have this rail in front of it. This will be mounted to the box. And then these drill guides we can put in an exact placement to guide the wire up onto the pickup. So this is just a 3/8 inch, I mean, they end up being really nice 304 stainless rods. They're really nice. They were, again, a couple dollars for a 2-pack. So that was nice. Very easy. These slide right on there, and because they're set screws, you could set them and lock them in place. So that will be that element of it. Some wire for when we need to wire things in. And then now the design of it, the reason why I put the notebook on here, the design of this box in general, whether we decide to go with a slanted design or a square design, for now it's measuring all of these parts and starting to draw out what we want our design. So what I'm going to do is I'm actually going to hook some of this stuff up and test it and make sure we get it to work. And then going to start measuring these parts. So it's going to be really as simple as, okay, the front of our box has to fit this screen in it, and we want it to slide in nicely, so that's going to have to be 2.4 inches will be nice by 1.4 inches. So it's going to be like that. It's going to be taking these measurements and then designing our parts to make this box around what we have to put inside of it. We're also going to try to mount the motor. The motor has a nice 6-way, an even 6M3 threaded mounting structure here, like mounting pattern. So we'll utilize that to mount this in the box. So let's set some stuff up and see if it all works. All right, can you guys see the little counter? So this is a pretty cool deal. See 0. This little guy right here is a magnet sensor, and so there's a little magnet on the back of this guy. See, there's like a little magnet. It comes off. It's just magnet stuck to this little piece of metal. But check it out. So every time this is going to, pass by as it circles around, it'll count how many winds is on the pickup. Pretty cool. So we wired the motor up, and the idea is that this will control the motor speed, and we have a separate on-off switch, even though this has an on-off function. So the first thing we have to do is turn this on, and then we should be able to, yep, there we go, see? So we got some motor spin, and then we could adjust the speed with that potentiometer up to its max speed. All right, so that's great. But one thing I did really think about is the point of this secondary switch on-off, which is redundant, was so that you didn't accidentally plug it in and it started spinning. Not that you'd load anything and have wire ready before you even plug this thing in, like to the wall or whatever, but the same risk exists anyway, because now this switch, wherever you place this, if you left it on, even if you went to go and say, oh, okay, let me turn the device on first, you still have to check where that is. So in the final device, I'm just going to get rid of this switch because it's pointless because it's built in here. So between all of the measurements and rough drafting what we end up having as our design, then we can let's jump into our software. So I've already done a lot of work, as you can see here. So we've already measured and designed out what our front panel is going to look like. And you can see that this has a window for the readout, for the counter. And this is also where that knob that controls the speed is going to go. You can see these little cutouts, these indents. Those make way for, here's the right side of the little box. Those make way for these arms that will stretch out and hold that stainless steel rod that will guide our wire up to where the motor is spinning the pickup. You can see the holes for the laser cutter that are going to cut out the mounting. These are through holes for M3 bolts that will bolt that motor right into place. The other side, tops, backs, bottoms, and sides, just all figured out once I knew what the box dimensions were going to be to fit all of the pieces. And then we have to design a part to hold the actual pickup, and that's what this starts to get at. This is a good example of iterative design. And, I mean, design test or failure at first. So I cut out a piece that I thought would go nicely and keyway this on the drive shaft for the motor, and then I could mount the pickup to what would be a circle that this piece mounts to. Here, if you got these two pieces, let me show you here. So this piece would mount onto the circle, and then the pickup would mount on the other side of that. This all gets put onto the drive wheel there, the drive shaft of the motor. Awesome. So what we end up having at the end of the day is all of these pieces. This guy actually goes away. These are the individual pieces. And to save you and spare you on some of the time, we're going to now go through some quick footage of laser cutting and some manufacturing steps, because I have to drill some holes to get to screw the box together. And then we'll, clear out some holes, scrape out some whatever's left in some edges, and then start assembly. So here we go. So this is post laser with the acrylic, and I started to drill some holes, but I figured I'd show you how it's becoming a reality. So we have some through holes here, but almost each of these pieces will require a little bit of additional machining so that we can have some holes to put screws in so we could assemble it all, and then also some countersinks and things so it all fits nicely. So I'm going to go drill some holes in the drill press. I'm going to do some final machining, scrape some edges so we don't have some acrylic melt, but also so we have some nice fitting parts. And then we'll be back here for what is assembly. Just giving a little chamfered edge here to some of these parts, making sure I have nice non-obstructed holes. As you can see, we have now drilled all the holes that we'll be screwing this together. So I'm going to save a bunch of video, save you a bunch of time, and we're going to peel plastic away and start putting the box together so we can start putting the pieces into it. we now have the workings of this box. I guess we'll find out real quick how we did. We did quite well. There's 2 screws on this retainer clip that hold this nice and sturdy. Sizing these holes, oh yeah, see, perfect. The nice part about using a dial caliper is that you can get pretty accurate. Ooh, that little part is schmutzed over, but that's okay. We'll adjust this when we get the wheel on here. This guy in, which magically we have enough room now for. And then something tells me it's a 10 millimeter, which it is. Throw that in there like so. Excellent. I think all things considered, I should have gone for some countersunk heads, but that's okay. It's starting to look like a pickup winder. Let's just because we can. There it is. Fast, slow, off. Tin this tip real fast. Okay, LP1. The ends of these wires are actually pre-tinned, so that is very easy. So that will go on here and spin the pickup, but also, so the pickup will mount on this side, but also we need it to have our little counter in there. Snug fit on here. Plug him on there. It's on really well and it'll count, but I don't think we can tolerate this amount of wobble. So we're going to have to figure out a way to really secure this on there, and it might involve making some other plates to keep this really nice and straight. Just jumping back here for a status update real quick before we go and probably take a break between maybe some redesign of a part or two just to make it perfect. Needs a base plate, but here's where we're at. We have a counter, we have a way to mount our pickup, see that, on a flywheel, and then we have the point of that rod again was so that we could set our guides for the inside and outside of our bobbins. And then, you know, design modifications being need to work a little bit on the flywheel to get it to rotate a little bit straighter, and then also in the future something that allows us to flip the direction that the motor's going to spin in. But do we have something that spins and counts? We absolutely do. I hope you can see it. 20, 30, scale up. We've set our guides. You can imagine feeding that wire and coiling that up real nice, especially if we really get going. Coming back to the desk here after figuring out some redesign work and figuring out some things that just worked out for the better. So with the flywheel, you know, we had some parts that really weren't. We had a set screw on the drive axle of the motor, and it just wasn't sitting flush, and so it was up for a redesign, something that was a lot more stable, especially when we want to wind these pickups reasonably well without issue. But instead of killing myself, Amazon, they just had an exact size metal flange. So they had a 6mm ID flange, which worked perfectly on this motor. So all I had to do is design a flywheel to bolt to that. So you can see the pickup on here just mounts with a through axle we put on the actual, you know, through the flywheel itself. Let me take that off. So all I had to do is, you know, put a new disc on there with a 4-bolt pattern to mount to that flange, which is a perfect idea and a set screw for that drive axle. And that magnet mounts in here perfectly as well. So that was very nice and easy. You will note we have called it the Sidewinder for obvious reasons. And then while we were at it, just ordered a double pole, double throw switch here so you can get clockwise or counterclockwise rotation out of the device. So let's check that out. So we can rotate backwards if we want to spin up the pickups that way. Or with a flick of the switch, we can rotate it this way. So it was, while the box was open, it just made sense to build that in if we thought we were going to use it, and it was a simple couple dollar switch. Literally, again, thanks to Amazon for same-day delivery on a couple dollars worth of parts. So we'll recap in the room, and I think what I'll do is probably do like a start to finish recap. But see you in the room. Sidewinder. All right, back in the room. Thanks for hanging on this long. Thanks for watching this far. What an awesome project building the Sidewinder, you know, cute little name for a cute little device here. But why buy something for a bunch of money if for under $75 or $100 or something in total, you can build your own? I mean, it was a lot of fun to do it. I have a blast doing this stuff. I think this is a ton of fun, let alone obviously being able to wind up this pickup next and put it back in an early 60s Fender Strat. So thanks for watching the video. I'll see you guys in the next one. If you liked this video, if you enjoyed watching this kind of stuff, like and subscribe to the channel. I'll see you guys in the next one. Thanks.